Hey guys, Mr. Bowman here. Today's learning objective is in white, and we are learning to determine the original equation from a derivative. So, key thing is, I'm going to underline the original equation. So before we start, hopefully you can recall the integration formula. So the integral of k times x to the power of n, that is equal to k divided by n plus 1 times x n plus 1 plus c. And the issue with integration is we've never really been able to figure out what this plus c might be. And today we're going to learn that, which will then give us the information to determine the original equation. So let's change pen colors, and I've got two examples that I want to go through today. So question 1, if the derivative is equal to 6x minus 10, and the original graph intercepts or goes through at 2, 8, what would the original equation be? So there's a two-step process for this. So first step, you do need to integrate to answer this question. So let's get into that. So we're looking to find the integral of 6x minus 10 dx, and that's going to be equal to 6 divided by 1 plus 1, because the power currently is 1. That's going to be multiplied by x to the power 1 plus 1. We're then going to go minus 10 divided by 0 plus 1, and that's because this power is currently x to the power of 0, and we're going to add 1 to it. That's going to be multiplied by x to the power plus 0 plus 1, and then we're going to add c to that. We're then going to just finish up. Let's simplify this. So this part over here, that becomes 6 divided by 2, which is 3x and then squared. We're then going to go minus 10x plus c. So that's the integral, and that's the first part. The next step is finding the equation. So let's actually move this up here. So step 2, finding equation. So currently, all the information we have is y equals 3x squared minus 10x plus c. But we also know one of the points, which is 2, 8, and at that point, x is equal to 2 and y is equal to 8. So we're going to substitute both of those values in. So 8 is going to be equal to 3 times 2 squared minus 10 times 2 plus c. And that leaves us with a plus c, which we can go through to determine. So 8 is going to be equal, so 2 squared is 4, 4 times 3 is 12, minus 20 plus c. So what we're going to get is we're going to get 8 is equal to minus 8 plus c. This is going to become 8 plus 8 is equal to c. C is therefore going to be, I've written 6, but there should be a 1 in front of that, 16. We've now figured out c. And the final step, I'll write it down the bottom here. You've got to state your equation. So we've now got all of the components of our original equation. So what I normally do is I normally go therefore y is equal to 3x squared minus 10x plus 16. And that there is the original equation from the derivative and the point we were given. So the key thing to emphasize, you can find the original equation as long as you have one of the coordinates given to you. Without that, you will not be able to find the original equation. Okay, so if you haven't got this example down, make sure you pause the video right now. Make sure you get it all down, including the steps. And what I'm going to do is I'm going to pause the video. I'm going to clear our working, and then we're going to get into our second example. Okay, guys, we're back. Second example. So if we know dy dx is equal to 3x squared minus 4x minus 7, and we also know it has an x-intercept at x equals 3, what would the original equation of this graph be? So like we did before, first step, I'm going to call it a this time. We do need to go through that integration process, so we do need to integrate. So we are looking to integrate 3x squared minus 4x minus 7. What would that come to? So let's actually work down our page. So we're looking at our formula. So that's going to be k, which is 3 divided by power plus 1, x to the power plus 1. We're then going to go minus 4 divided by 1 plus 1. Just a reminder, x by itself would have a power of 1. That's going to be multiplied by x, also to the power of 1 plus 1. We're then going to go minus 7 divided by 0 plus 1. And just to note that there would be x to the power of 0. And then x, 0 plus 1. And then at the end, plus c. And that's the thing, that's the main issue that we're trying to solve. We can then wrap up our integration. So we've got 3 divided by 3. That's just going to be x cubed. We're then going to minus 2. So 4 divided by 2 gets us to that. And then x squared. We're then going to go minus 7x. And we're then going to go plus c. So that's our integral. That's the first point that we're looking for. Okay, the next step would be to solve for c. So I did word that slightly different in the previous one, so use the wording that you like. So we're trying to solve for c. At the moment, we know that y is equal to x cubed minus 2x squared minus 7x plus c. And we also know about the x-intercept at 3. And that as a coordinate would be 3, 0, which means our x value, that's going to be 3, and our y value, that's going to be 0. So we're going to substitute both of those values in, and let's try to solve for c. So 0 is going to be equal to 3 cubed minus 2, 3 squared, minus 7 times 3 plus c. And from there, we're just going to simplify and solve for c. So 3 squared, that's going to become 27. That's going to be minus, so 3 squared is 9. 9 times 2 is 18. 3 times 7 is 21. And then we've got plus c at the end. So let's clean. What does all this come up to? So 27 minus 18 is 9. And then 9 minus 21 is negative 12. And we're going to add the c back, and that there makes c equal to 12. So we've now solved for c. The final step, wrapping it all up, you've got to state the equation that you've just figured out. And in our case, therefore, we're going to use the bit up here with the c to state our final equation. So y is equal to x cubed minus 2x squared minus 7x plus 12. So we've gone through 2 examples. Hopefully you found these useful, really important. Make sure you get the steps down. Make sure you understand every single thing. And once you've done that, move on to some questions. All right, let's go.